In this video, I'll be guiding you through MongoDB's GridFS, a powerful tool designed to efficiently store and retrieve files of any size, complete with metadata. It's an ideal solution for applications that need scalable and flexible file management. Let's dive right in and get started. First, let's get started by installing the necessary library from NuGet packages. Search for mongodb.driver.gridfs and install it. Next, we'll set up the connection string in the app settings file. Since I already have MongoDB installed locally, I'm using localhost along with the database name. By the way, the source code for this project is available exclusively for our Patreon supporters. If you're not a member yet, consider joining the community to enjoy exclusive benefits. Just follow the link in the description below. Make sure you modify the connection string to match your database connection. Now, let's register the MongoDB database as a singleton dependency service in the application. Next, let's create a service named MyBucketService to manage files using MongoDB GridFS. To start, I'm defining string constants for the bucket name and chunk size in kilobytes. In MongoDB GridFS, the chunk size determines the maximum size of each segment into which a file is divided for storage, enabling efficient management and retrieval of large files. By default, this value is set to 255 KB, but for this demo, we'll use 100 KB. I'm declaring a private read-only object of type GridFSBucket, which will be initialized in the class constructor. In the constructor, we'll inject the database object and create an instance of GridFSBucket options to set the bucket name and chunk size. Since the chunk size needs to be provided in bytes, I'll convert the kilobyte value accordingly and then instantiate the bucket object. If you're using C#9 or above, the initialization can be simplified further. Next, we'll create a method to upload files. This method will return the file ID as a string and will accept the file name, tag, file content, and content type as inputs. The tag will be useful later for filtering files. I'll create an instance of GridFS upload options to set metadata values such as content type and tag. Metadata in MongoDB GridFS provides additional details about a file, making it easier to organize and retrieve files. Using the openUploadStreamAsync method from the GridFS bucket, we can get a writable stream for uploading. I'll fetch the file ID from the stream, write the data to the stream, and close it upon completion. Finally, the method will return the file ID. Now, let's create a method for downloading files by their ID. This method will return the file content, file name, and content type. First, I'll define a filter object to find the file information matching the ID. Using this file info, I'll retrieve the content type from its metadata. Then, I'll download the file from MongoDB and return its content, content type, and file name. Finally, we'll add this service as a singleton dependency service to the application. You can use this service in any type of application, but for this demonstration, I'll be using a web API. Let me create an API controller named FileController. First, I'll create a get method to download a file by its ID. We can retrieve the injected dependency of our service through the controller's constructor. Using the service, we'll fetch the file details and then return the file by providing the file content, content type, and file name as parameters. Next, let's create a post method to handle file uploads. This method will accept a tag along with the file as part of the request. We'll copy the uploaded file from the form file object into a memory stream. After that, we'll use the upload method we created earlier to save the file. Finally, the method will return the generated file ID as the response. When we run the application, we can see both methods we created. Let's start by testing the upload method. We can provide a tag value and choose a file to upload. I have some image files here for testing, but you can upload any type of file. After executing the method, we can see the returned file ID in the response body. Let's check the entries in MongoDB. You'll notice that two collections have been created. The files collection, which contains the file information including metadata, and the chunks collection, where the file content is stored in multiple chunks. Let's upload two more files to see how they are handled. The new file details are also successfully updated in MongoDB. Now, let's test the download method by using one of the file IDs. When we execute the method, we can see a download option in the response body. Let's download the file and open it. And there we have it. The file successfully downloaded from MongoDB GridFS. I've also created two additional API methods. One for fetching file details in JSON format by filtering with a tag, and another for deleting files from MongoDB GridFS. Let me show you how these methods work. To get a deeper understanding, you can check the source code available in our Patreon community. If you are not a member yet, consider joining to access exclusive benefits using the link provided in the description. Previously, we uploaded all the image files using the same tag. Let's now upload a new file with a different tag. This time, I'll upload a PDF file. The upload is successful and we've got the file ID as the response. Now, let's fetch the file details by filtering with the tag. First, I'll use the previous tag, and as expected, we see the details of the three image files we uploaded earlier. Next, I'll filter using the new tag, and here are the details of the PDF file we just uploaded. Let's try downloading this PDF file. The file is returned in the response. I'll download and open it, and here it is. The file successfully downloaded from MongoDB GridFS. For a more in-depth look, don't forget to explore the source code in our Patreon community. Also, if you want to learn more about MongoDB CRUD operations, check out this video linked in the description. If you found this video helpful, please like, share, and subscribe to the channel. I'll see you all in the next video. Thank you.